Okay, Calc Gang, we're on to example 3 in your notes. Here we go. Let's see what the movie looks like. We've got a cop approaching a right-angled intersection from the north. He's chasing a speeding car which has turned the corner and now is moving east. They tell you the cop is 0.6 miles north of the intersection, and the car is 0.8 miles east of the intersection. The cop takes out his radar and sees that the distance between them is increasing at 20 miles per hour. If the cop is moving at 60 miles per hour, what is the speed of the other car? Okay, so see if you can figure out what this movie looks like. I would suggest pause the video and see if you can draw the movie. Okay, then restart the video and see if we're on the same page. Alright, so pause the video now if you want to try to do that. Okay, hopefully you drew what the movie looks like. So I'll draw it for you now. So you've got the cop. Okay, he's coming from the north side of the intersection, and you've got the speeder on the east side of the intersection. So the cop is coming this way, the speeder is going this way. So over time, the cop should be getting, you know what, can that, I don't like how far away I made that. Let's put the cop farther north. Let's put the cop farther north. Let's put the speeder closer here. Okay, speeder for S. Okay. Alright, I like this version better. Alright, so the cop, he's going to drive this way, right? He's heading towards the speeder. The speeder is trying to move away from the cop, so the speeder's going that way. So over time, I'm just going to do C for the cop. So over time, this side should be getting shorter, this side should be getting longer, right? So over time, right, because the cop's coming down this way, the speeder's going that way. Right, so over time, this side should be getting shorter, this side should be getting longer over time, right? This side should be getting longer, right? The speeder is out over here now. Like this. That's the movie. Alright, so when you think of the general picture, you've got the cop guy over here, wherever the speeder is, let me just put it here, and the cop puts his radar on the speeder, like that. The cop put his radar on the speeder. So that's what the general picture is going to look like. That's all the information they're talking about. So now I want you to think about what's a variable and what's fixed. I want you to fill in everything that you can say about the general, okay? And if you have some knowns and unknowns you want to write on the side, that's fine. But those are more for the specific. I want you to think about the general, meaning, is this side changing with time? Is this side changing with time? Is this side changing with time? Because we're talking about the three sides there. So think about that for a moment. You can stop the video if you want and try to do it yourself. Okay, so you should notice that this side is changing with time. I'm going to call it Y because it's vertical. My brain likes Y for vertical. Right, because this side is changing with time. I'm going to call this side X because this side, again, is changing with time. But also, this side's changing with time. So if you notice, if I start to pull this, right, this side's changing with time, right? So I'm going to call this S. Okay, so all the sides are going to change with time. So that's the general picture, and off of the general picture is what you write the general equation. So all the sides are variables. So let's then write the equation for this. So the equation is going to be it's a right triangle. So the equation is going to be what? The Pythagorean theorem, right? X squared plus y squared equals s squared. Okay, and now try to take the derivative of that. Stop the video and try to sort of do a little bit for yourself and then start the video again. See if you know how to take the derivative of that in respect to time. Okay, hopefully you tried that. I'm going to now do it for you. So the derivative of the 2 is 2x. The derivative of the x is dx dt. The derivative of the 2 on the y is 2y. The derivative on the y is dy dt. The derivative on the 2 is the 2s. The derivative on the s is ds dt. Now they all have a 2, so I can cross it out. I can like divide everybody by 2, and that would get rid of it. So I really just have this left. Alright, so that's as far as I can go right now with the general. I now have to go back and figure out what's the specific picture. Okay, so let's figure that out now. And this would be a good time to also stop the video and see if you can figure out what is the specific. Okay, so now I'm going to do the snapshot or the specific picture. So again, you stop the video if you want to try to figure it out yourself and then check with what I did. Okay, so for this specific video, I've got a snapshot for like when you pause the scene here. I've got to go back now and look at the problem. The cop is 0.6 miles north, so that means that the snapshot, at the moment we're looking at, the cop, which is sitting here, is 0.6 miles from the intersection. So y is 0.6 miles. Y is only 0.6 miles at the snapshot. If you say that that is always 0.6 miles, you're saying that the cop is sitting there and he's not moving. Okay, do not put 0.6 into the beginning. If you put it into the beginning, you're saying that it's always 0.6. Don't do that, right? Because you want to say it's always changing. That's why you put a variable, because it's always changing. It's only 0.6 at this moment. Okay, now, the speeder is 0.8 miles east. So that means that this guy over here is 0.8 miles this way. And we don't know yet what this side is. What else do we know here? The police determined with a radar that the distance between them and the car is increasing. Okay, so that's the derivative of s, because that's talking about this side. So that's your ds dt. And it's increasing, so it's positive. Okay, which the cop probably isn't too happy about. So if the distance between them was decreasing, then that would be negative, okay, but it's increasing. All right, let's see if we know how fast either of these guys are going. The cop is moving at 60 miles per hour. The cop is y, so dy dt is 60 miles per hour. Now you got to watch, because this is a little tricky here. This side is getting smaller. This side is getting smaller with time, which means that its corresponding derivative has to be negative. Has to be negative. Okay, it's a little tricky. Okay, and then what is the speed of the speeder? So we're actually looking for this derivative of this guy, dx dt. That's the guy that we're looking for. Now, if you come back to the equation for a moment here, and we solve this for dx dt, because that's what we're looking for. So now we know what we're looking for now. So we're gonna isolate dx dt, because we know that's what we want. So I gotta move this to the other side. I gotta divide off this. So if you notice, this is what we're going to plug into, because we've isolated everything we need here. But if you notice, we're going to need S. We're going to need S. We have to have that to plug this in. So we're going to have to find that. So sometimes you have to dig for some information. Sometimes not all the pieces are given. So to find S, what do you think you're going to do? If you have 3 sides of a right triangle and you're missing one side. Good. I hope you're saying Pythagorean theorem, right? Because we have to find S. Okay, so we're going to do x squared plus y squared equals s squared. X is 0.8 squared. You might recognize this. This is a version of a popular triangle. This is 0.64. This is a version of a popular triangle, so you might know what this is. Okay, so this is 1 equals s squared, so s equals 1. So this is a variety of the 6, 8, 10, but it's going to be 0.6, 0.8, and 1. And it's going to be 1 mile. Alright, so now we can plug in. We now know all the bits. We know all the parts. So let's try that. Okay, so plug in now. Plug in. So dx dt is equal to, alright, s we said was 1. ds dt we have is negative 60. Oh, sorry, ds dt is 20. My bad. Let me maybe plug in over here. Okay. So for the plug-in. Okay, so dx dt. So we said that s was 1. ds dt we said was 20. Y is 0.6 times dy dt, which is negative 60 over x itself, which is 0.8. Okay, so let's see what that crunches out to. Dx dt equals to 20 minus, oh, it's going to be a double negative here, so I'm adding. That's going to be 360, but I got to move 1 decimal place. So 360 move 1 decimal place is 36 over 0.8. The x dt is 56 over 0.8. Which is 70. Okay, so now put the unit on that. So that has to be in miles per hour. Okay, so let's just go back over that real quick to make sure we're all on the same page. I hope you enjoyed that. I think this is like a really good example to sort of get the gist from. It's difficult, but it's not like massively overwhelming, hopefully. I'm hoping. Okay, so again, we first draw the movie. The cop's coming this way to the south, so this side is shortening. The speeder's going to the east, so this side is getting longer. So we decided that all the sides are changing. The side the cop is coming, the speeder, the distance between them. So all of the sides were changing. That's what we decided from looking at the movie. So then we write an equation that describes the general. So the general is a right triangle with 3 missing sides. So that would be, sorry, let me say that a little better. The general picture is a right triangle where all the sides are variables. So we would use the Pythagorean theorem for that, and not trig, for instance, because there's no angles. There's no angles in this one, so we wouldn't even think of trig. You need an angle to do trig. So, or you need to be talking about the angle to do trig. So these are we're just looking at the sides. So we use the Pythagorean theorem. We take the derivative in respect to time of the Pythagorean theorem. We isolate what we're looking for. In this case, it was dx dt. We figure out what the specific moment in time, what's happening, how far the cop is, how far the speeder is, how far the distance between them is. We figure out what our knowns and unknowns are, what we're looking for. So we figure all that out so that we're then able to plug it into the general equation that we've isolated. So then we plug in the specific is what you use in the plug-in, right? This is where you use the specific information here in the plug-in. So now we go to the specific picture for the plug-in. We plug in everything we're looking for, and we find out that the speeder is going 70 miles per hour, And that's that. That's a wrap. So I hope you enjoyed this one, and I will catch you again soon for the last example in the packet. Okay, bye-bye.